courses that I'm coming up with Isha Training Solutions. That's called Cloud Performance Engineering and DevOps. So the agenda for today's demo is to understand the topics that we are covering, and if anyone has any question on the that course, called Cloud Performance Engineering and DevOps, so ask any question and clarify your doubts. Okay, so that's how we'll get started with. Okay, so just a background about me, guys. I have my name is Roshan. First of all, I have around 15 years of experience in IT. I have been working predominantly. I have a significant part of my career. I have been working as a performance engineering, kind of 6 years. I have been into performance engineering out of my total 15 plus years of experience. I started my career as a Java developer, and recently, after that, after Java development, I was into performance engineering, and then I moved into DevOps part of it, DevOps, SRE, Python development, and all those stuff, automation using various tools like Terraform, Ansible, Jenkins, CI/CD pipeline. So that's the brief about me, guys. Currently, I'm working as a principal SRE with one of the reputed big retail giant, and I'm basically a DevOps consultant, SRE and DevOps consultant currently. Okay, so this is going to be the agenda for this particular demo. We'll start with a question, okay? And then we'll understand the software development and deployment evolution, how software has been developing and evolved over the years back. So from 1970, when the software industry started, how things have been developed and deployed over the years. That's what we'll understand, and we'll understand what's going on today. And then we'll directly talk about the course syllabus, what we have to offer, how this can benefit this course can benefit you, and we'll have some question and answers. Okay, so that's what the agenda for this particular demo. So before I get started, guys, I have a question for you. Okay, so I do assume that most of the folks those who join this kind of demo are mostly from the performance engineering background. They're mostly from either they are performance testing, into performance testing, working with tools like Jmeter, Load Runner, Gatling, right? Or they are basically performance testing, or engineering and testing background. That's what the most of the audience I have been getting in this kind of demo session. So please confirm if you are in the same category, yes or no. Quickly, if you can confirm, I can proceed with that. Okay, please confirm, guys. All of you use the chat option, guys. Okay, so I do see one no here. That's no problem. We'll check. Anand, so what's your background, Anand? Could you help me understand so that we can make sure that okay, manual testing. Okay, great. Indra ready. Okay, good, guys. I'm a perf tester. Charan, good. So Anand, please help me understand, Anand, about your background so that we can see what can we do better, how you can leverage this session, and if I have something for you, we can definitely help. Guys, feel free, please help me with your inputs. Okay, completed my master's in business analytics. Okay, so I'm hoping that you are looking for such a course, Anand, because you are completely from a different background. So I'm hoping you are looking for something in the performance testing engineering cloud part, right? That's why you're attending this particular workshop. That's what I can think of. Good to know. Well, we'll take up that. Okay, so okay, guys, that's fine. I've understood most of the folks, and I think I do see one folk from performance manual testing. So Indra, I think the motivation for you would be to understand, explore what's performance testing and how cloud performance engineering is all about, right? I think you want to explore that, if I'm not wrong, Indra. Yes? Okay, great. So we'll start with, guys, and slowly I think you'll understand what we're going to cover and how it can benefit you. I'll try my best to make this 1 hour of this time your worth, and you will have something to take away, something to learn from this 1 hour. I can definitely vouch for that. I'll try my best. Okay. So guys, one of the questions. Okay, we'll start with this question. So we all are from a different background, mostly performance background. We are into, and some of you from business analytics, and some are from manual testers. Help me answer this question. Do you guys think that performance testers, engineers are expected to know this as per the current market trend that you have been experienced taking interviews about what they ask in the interview or what the job description looks like when you join a company? Do you think that there is a need for you to learn DevOps, to know about microservices, to know about containers, Kubernetes, cloud? Do you guys agree with me on this part? How many of you agree with me this part on this? Guys, please help me understand. How many of you agree that yes, that we need to know this or no idea? Okay, I am getting responses. Sound Sutanu saying yes, agree, Anand saying yes, Megha saying yes, Indra saying yes. Okay, great guys. So this is what, right? This particular course, Vino is saying yes, Charan is saying yes. Yes, perfect, good. I hope we are all in line with each other. Even this is what this particular slide I have designed 2 years back, and still we are in the process of doing this. So 2 years back, still relevant. These technologies are still developing. 2 years back, when we started with this particular course, I knew that this is going to be the hot kick in the market, and every performance tester or manual tester or any QA engineer would need to know this. Anyone in DevOps, anyone would need to know this, right? And we'll put things in perspective. Okay, we need to understand where this DevOps, microservices, containers, cloud fit basically in the software development and deployment evolution. That's the main understanding where it fits. So that will be clear for my next slide, which I'm going to project here. Look at this. If you look at this slide, guys, everyone. So we talked about DevOps, right? We talked about DevOps. So this is where DevOps fit in. If you look at when the software development started, we all know, right? If you're from IT background, we all know that it started from waterfall model, right? Back then it was all waterfall. That's how we started. It has a lot of issues. I mean, Anand is saying I'm in Ireland, his first demand job. That's good. Good to know, Anand. Okay, guys, please focus now. So we all know that back in 1980s, it was all waterfall. That's how software development process started. We didn't know about agile. It was good to get started. We know that it has a lot of issues because in the waterfall model, how it took, because we developed the entire infrastructure, we developed the entire application all at once, and then we started to test it. It was not fruitful. That's what we found, because you cannot go back and change things. If you have made some architectural mistake or some flaw is there, you cannot go back and change it. And you have already developed the application, right? It was one of the things which we should avoid and that we are avoiding in the future. But it was good to get started with such a waterfall model. We started with waterfall and then we moved into agile. We are still in agile. So what we did, we divided the same software development into multiple phases. We call it sprints: sprint 1, sprint 2, sprint 3, sprint 4. And we did not develop the software all at once. What we did, we divided into phases. Phase 1, phase 2 we called, and then we did the development, we did the testing, we did performance testing, we did everything on the SDLC required. And then we went to the client and asked, are we on the track? Are we on the right track? Do you have any feedback for us to implement that we can do in the next phase? So we got the feedback, we implemented it, we developed the second phase, we again did testing, development, all the process started. And then we took the feedback again, we moved to a third sprint. And that's how the software development continued. And it was quite a stable way of development, the agile way of development. That's what the agile way of development means, right? Still, we are into agile, but now we are into DevOps phase. What we do, we are into agile, but we want to automate everything. Automate everything, what does it mean? When the software is ready, when the code is ready, when the code is ready with the developer, when the developer is ready with the code, what is the end result? What is the end thing that we want? I want that code to be deployed in production. That's what I want, right? That's what we want. We want the code to be deployed in production as early as possible, as swift as possible. That's what we want. How soon we can do this? In the agile, it took a lot of process. It took a lot of time before we deployed the code to production. It took months because a lot of things happen during when the developer is ready. We tested it. We did all the quality validations. We did performance. We did functional testing. First of all, we built the code. We developed jar file, war file. We did the unit testing. Then we did functional testing, quality validations. Then when we did performance testing. Then we did security testing, penetration testing. All these things, right? We did many stuffs in between. Build the code, functional testing, performance testing, penetration testing, security testing. We did all of these things to make sure that my code is stable in production. And these steps are required. I'm not asking you, DevOps doesn't ask you to skip these steps. DevOps main focus is to automate these many steps for you so that when the software is ready, it takes very less time for you to deploy the code in production through automation. I want to automate all the steps. That's what DevOps is all about. If you ask me the definition of DevOps, I'll simply put the automation of SDLC. SDLC automation is all about DevOps. Because when the code is ready, I want that code to be deployed in production at the earliest without compromising on the quality validations. I want the code to build successfully. Functional testing I want, performance testing I want, penetration testing I want security testing I want UAT testing, and then if everything goes good, I want my code to be deployed in production at the end. Because the customer experience, the user experience, the customer experience is at the utmost priority. That's what matters. And if I don't do this quality validations, I'm going to compromise things. We don't want to compromise things, right? So what is the best way to automate this? And that's what DevOps brings. DevOps brings automation. That's what. So this is what we are into this development phase. Look at this waterfall, agile, and DevOps, right? So this is about the development process. The same story goes on with the application architecture. So we started with monolithic applications back in those days. It was all monolithic. When I say monolithic, what do I mean? If you have one application server, let's say you have a 3-tier application. I'm showing you this. This is also monolithic I'm showing about. Let's say you have a 3-tier application: web server, app server, database server. In the app server, you have all the modules tightly coupled. It means you have only one jar file. Consider a project in Eclipse where you have a lot of classes and a lot of methods, and all those classes, a lot of packages, and in the packages, a lot of classes, in the classes, a lot of methods. All these methods are getting called anywhere and everywhere across all the packages, right? So you at the end you get only one jar file. There is a huge dependency in the code at the code level. It's a tightly coupled monolithic. What we call it's a tightly coupled, right? The problem with monolithic, if the issue with one of the module, it can bring down the entire application. If the issue with one of the functions in one of the module, let's say this module M2 has 20 functions, F1 to F20. If the issue is with one of the functions, let's say F10, it can bring the entire application down, because F10 would be used in M3 or M4 or M1. It could be used anywhere because the code is being called anywhere and everywhere across my project, Java project, because we have a lot of packages, a lot of classes, a lot of methods, and we are calling the functions anywhere and everywhere. So there is a huge dependency in case of monolithic application. Monolithic application by itself gives you, it's a risk to high availability, right? And that's when we understood, and we all the development, if you see right now, it's all happening in the microservices domain. Everything microservices. We don't want the function to be called, direct functions to be called across modules. If I have 5 modules, M1, M2, M3, M4, M5, whatever I have, I'm not going to call the functions directly. This microservices could be developed in Python. This microservices could be developed in Java. This microservice could be developed in Go language. This could be developed in JavaScript, right? So this gives us that level of freedom. microservices. And the best part of microservices that if one microservices goes down, let's say some issue happened to one of the microservices, it is not going to bring down the entire application. It is same as, right? Let's say you use Uber application or you use Swiggy application to order your food. You use Uber application to order your cab. If I tell you in the Uber application, if a notification module is not working, you cannot book your cab or you cannot order your food. How ridiculous. It doesn't make any sense. If a notification module is not working, why it should impact my other modules? It should not impact. And that's what microservices brings to the table. It makes sure that your one microservices, one module doesn't impact with the other module, right? That's how microservices are designed. It gives you high availability. And that's why we have moved from monolithic architecture to microservices. We need to learn. I hope some of you, most of you, I think would be testing in using some Jmeter or Loader and must be doing API testing. Nowadays, earlier, 10 years back, or I would say 8 years back, we used to do mostly web testing, web-based. Now it's all about HTTP. It's all about web services. We do API testing, REST API. That's what we call. We use Jmeter scripting. We do API testing most of the time. If you ask me 10 years back how we used to do, it was mostly web testing, web-based. Web-based is still applicable. I'm not saying that, but it's microservices-based architectures that's what we are developing more, because we understand the importance. It gives high availability in its architecture itself. That's the benefit it offers, right? And where to deploy these microservices? That's the next question. Okay, I split this. I split monolithic applications. Good. I created microservices. Good. But where to deploy this? That's the next question. Back in 1980s, when the virtualization was not there, not even VMs was there, we used to deploy software directly on the physical server. 100 vCPUs, 100 GB RAM. Consider one physical server with 100 vCPUs, 100 GB RAM. And we deploy some KB, MB application. What are we losing here? We are not doing cost optimization. We are wasting a lot of resources. Back then, it happened. It was good to get started. We should not blame the past. It's always to get good started with something, right? It was a good thing. Then we progressed and we invented something called virtualization. I hope some of you are aware of virtualization. You guys must be working on VMs. That's how on this physical server, we install something called virtualization software. VMware is the pioneer in this. We have a lot of Hyper-V from Windows. We have VirtualBox from Oracle. We have many softwares now. And once we install virtualization software, we could create VMs out of it. From the same physical server, we install something called virtualization software, and we could create VMs, a lot of VMs. Now, since we have a lot of VMs, we can deploy multiple applications on the same physical server. We can deploy multiple applications. We can deploy applications separately. We can use one VM for app server, one VM for database server, one VM for web server, one VM for another application. We can use different VMs. We can now, where we used to install one application in one VM, one physical server. Now I can use the same infrastructure and we could create VMs, multiple VMs, and we can deploy multiple applications. It was a great achievement on the optimization part, of infrastructure optimization part. We saved significant dollars here. The cost is at the center of everything. Cost is at the center, right? Innovation you do, cost optimization. Because if you optimize the cost, if you reduce the cost, you can invest the same amount somewhere else in the development, in the research, R&D. Cost is at the center for everything. Right now, also the cost is at the center. And that's when we realized that whatever the VMs that we are running, it is also not fully utilized. And we noticed that mostly the VMs are 10% or 20% utilized. If you install, let's say, 3-tier application, web server, app server, database server, let's say that, we noticed that the VMs are hardly 10-20% utilized. We are not utilizing the resources of these VMs fully. So what is the best way? To make sure that we utilize the resources, why not to use the cores and the RAM that we already have it? We should use it. So how can we make sure that we use it? We come across one technology called containerization. Containerization. We created containers on one VM. So what we did, we took one VM, we installed something called container engine like Docker, and we could create multiple containers. What does it mean? Let's say you require 3 VMs to run 3-tier application. Let's say your app server in one, web server in another, database server in another. 3 VMs you required. Now I'll take one VM and I will create 3 containers in it. One container could be my app server, another container could be my web server, another container could be my database server. Why do you think that I could save the cost now? When this VM is fully utilized, then only I'll go and ask for the next VM. So basically, what I'm doing here, I'm optimizing the cost. I'm making sure my VM is fully utilized. And on the application front, on the performance wise, no compromise. App server, web server, database server, no compromise. And the best part, this microservices architecture suits perfectly well with these containers because we host our microservices. What is microservices? Just a piece of code that we need to run. It's not a full-fledged application. It's a part of the main application, right? And we can deploy this microservice on the containers. That perfectly gels well. That gives us enormous significant utilization of the resource. We could do a lot of cost saving. So container Docker is the container engine here. And it's not about Docker. We need a container orchestration engine as well. We need automatic scheduling of pods, auto scaling of pods, containers in the production. We don't want to sit and do things manually. We want automatically things to be done. That's why we need a container orchestration engine like Kubernetes. So that's why we're talking about Docker, containers, Kubernetes nowadays. That's why you understand the importance from this, and then you relate why these technologies are in demand. Obviously, this has to be in their demand because this gives you cost optimization. Every company would like to implement this. If you implement Kubernetes architecture, you're going to be highly reliable in production because of its feature that it offers. Kubernetes offers. Being the container orchestration engine, it offers a lot of features that gives you high reliability in the production. We'll talk about it Kubernetes some other day. Let's get on with the topic, right? So now these 3 things we talked about. Then obviously the infrastructure, how we use the infrastructure. Earlier, if you have a business idea back in 1980s, if you have a business idea, you don't have any other option but to set up your data center. You had only this option. And setting up a data center is not that easy task. It requires a lot of significant dollars. Heavy investment. Or most of the ideas were getting crushed because no one can afford to set up a data center. It was always the big players' game. Software development was a big player game. It was not an easy task to do. And nowadays, if you talk about it, we are into phase of cloud. Getting the infrastructure, getting the servers is a cakewalk because everyone can pay monthly bills. Everyone can do monthly bill. Everyone can do my monthly bill. But it was not that of a simple process back then, right? Now we are into cloud phase. We're talking about AWS, Azure, GCP nowadays. Getting the infrastructure, it's no more a hurdle. It's no more a hurdle now, right? We can easily go to AWS account, create it, go to Azure account, GCP, and we can create some servers. It's difficult to pay $1 billion, but it's easy to pay $5,000, $5,000 monthly. It's difficult to invest so much in setting up a data center, but most of them can afford paying $5,000 or $10,000 on monthly basis. That's what we'll talk about cloud. And that's where, so nowadays we are in this phase. Understand when I ask the first question, I asked this first question, and now we have put the things into perspective. Where this fits in, DevOps, microservices, containers, cloud. That is where these things are important nowadays, because these are the latest things going on right now. And obviously these have to be in the demand, and that's why people are looking for it, asking for these things. Any questions, guys? We're gonna talk about the course syllabus now. Do we have any questions till this point of time?
What is the difference between container and a pod?
Okay, see, when you use container engine using Docker, you create containers. Okay, when you talk about containers, Docker engine, you create containers. Pod is very much specific to Kubernetes. Okay, so there is not much difference, I would say. So containers and pods. Okay, so basically pod is also having container. So pod is like an encapsulation. So when you talk about Kubernetes, we don't use the word container. When you talk about Docker, we use the word container because that's how the industry uses it. But when we use the Kubernetes recommends you to use the word pod. Why? What is the pod and how it is different in container? Pod is like an encapsulation around the container. When I say encapsulation, what do I mean? So let's you have this pod. The container runs inside the pod. So this is the pod and this is the container. So the encapsulation around the container is called pod. One pod can have multiple container also. But the difference is there will be only one main container. Other container would be the helper container, like data pullers, pushers. I'll push the logs. I'll pull the logs, right? Sidecar like of a thing, or act as a proxy. So this is the difference between between pod and the container. So it's an encapsulation. We use this pod in terms of when we talk about Kubernetes, and one pod can have multiple containers, but 99% of the case, one pod will have only one container. I hope it's clear now.
Okay.
Sure. Any more questions in whatever we have discussed so far? Anything, you can ask me any question, guys, in whatever we have discussed so far. I'm going to give another 1 minute. Okay, I don't think so. We have question. All good? Okay, perfect. So guys, coming to the course syllabus that I'm coming up with, I'm going to cover all these things: cloud, containers, microservices, DevOps. All this part would be there in my course, along with Java performance engineering. I'll talk about the course that we have now. Okay, I'm going to project my screen. This is the course that I'm coming up with. If you look at this, what all we are covering here, we are talking about AWS cloud. We just talked about how cloud is important. We're talking about AWS cloud from scratch. So if you ask me what is the USP of this particular course, I know the people, the background they're coming from. I do, when I take up any topic, I make sure that I speak about anything from scratch. I assume that my audience doesn't know anything about these things at all. That is what I'll take up things. So be rest assured that whether you'll be able to follow or not, even in 10th standard, 12th standard, people can follow it. It's all about knowing things, right? Different world. It's that way. I take up in that way, right? So AWS cloud. Nowadays, it's all mostly about the Linux. Okay. So if you talk about containers, Kubernetes, it's all about Linux. We mostly deploy things in Linux operating system. So I understand this, and we have taken this Linux course as well from scratch. If you don't know Linux, we'll teach you Linux. So it's going to be from very scratch. So the idea is that I want you to feel as comfortable in Linux as you are with Windows. If in Windows, if I ask you to open one directory, you can do that. Double click directory, you can do that. Open your file, double click, you do that. But if I ask you to do the same thing in Linux, will you be able to do that? Right? Navigate through directory, open a file, open a text in a file. If I ask you in Windows, you can do that. Control F. But can you do the same thing in Linux? Right? So basic things, right? Navigations, permissions, users, groups, and a lot of commands. Linux performance commands, basically top command, mpstat, vmstat, what does it do? Self-scripting, till self-scripting we'll talk about, okay, in the Linux part. Okay, coming to that, we'll talk about ECS, that is called Elastic Container Service. Again, is one of the service in AWS. We'll talk about Docker, and we'll talk about ECS. We'll talk about RDS, Relational Database Service, database part that we have. We'll talk about microservices, Docker, Kubernetes, as you just talked about, right? EKS, in EKS is one of the service. Kubernetes is this much popular that every cloud service provider, AWS has come up with service called EKS. GCP, Google Cloud Platform, has come with GKE. Azure has come up with service called AKS. Kubernetes is this much popular. Every cloud service provider has come up with a managed service. So EKS, Elastic Kubernetes Service, is from AWS. Google Kubernetes Engine is from GCP. Azure Kubernetes Service is from Azure. So we'll talk about EKS and GKE. I'll do the hands-on on the GKE, and I'll provide the recorded videos on the EKS part. I'll explain you. After just the installation part is the different. After that, it's Kubernetes commands is the same. kubectl commands is all same. So we'll talk about Kubernetes part in detail, right? We'll talk about EKS and GKE as well. I have mentioned in the course detail, but GKE also mentioned this here. You Google Kubernetes Engine. We'll talk about Jenkins. It's all about automation nowadays, right? In the DevOps world, it's all about automation. How do you automate things? So why it's important? Because as a performance engineer, you need to also contribute to the CI/CD pipeline using some performance job. Because when you create a CI/CD pipeline, because when the software is ready, I want to deploy the code to production. When the code is ready from the developer, it has to be deployed to production, and you need to do a lot of quality validations. Build the code, functional testing, performance testing, security testing, penetration testing, UAT testing, and then at the end, the code needs to be pushed to production. So I'll talk about how do you create a performance job? How do you do performance testing here? Automated testing, performance testing. We'll talk about that using Jenkins, CI/CD pipeline. We'll talk about that. And we'll talk about Java performance engineering as well. Very important. Heap dump, thread dump, GC algorithm, JVM architecture. We'll talk about all these things. So this is what I'm coming up with this course, guys. So this is going to be from last 2 years. I'm taking this particular course. This is going to be my, I think, 10th batch with this particular course. Before going to the deep dive, I'll show you what you get in the end. You will be getting the recorded session for each. So right now, as we are recording, right? Similarly, you will be getting recorded session for each of the recordings. You will get something like this. Look at this. This is the batch, June batch. If you look at exactly how things have been covered, AWS, security group, VPC. I talk from very scratch. Introduction, EC2s, S3, Linux command line, right? VPC, NAT, NACL, microservices, container, Docker file, Docker volume. So we'll talk about. So this is how you will get the recorded session, CI/CD pipeline, and a lot of it, right? So this is not the end. This is this is what I'll take up during the online classes. After that, not able to hear anything. Bharat, am I not audible? Well, guys, Bharat is saying I'm not audible. Please confirm if I'm audible. Guys, please confirm if I'm audible. Bharat, please check.
Yeah, you're audible.
Okay, Bharat, please check the connectivity from your end. Okay, so this is what you will be. This is the regular sessions, guys. If you just click on any one of it, this is the regular session that I take up. Okay, the way I'm recording right now, the same thing would be displayed. I will be sharing on a daily basis as when we'll be recording. It will be the real class that I'll be sharing the recording with. Okay, if you just see that, yeah, that's how it will be. Okay, I'll be sharing these things with you, right, on a daily basis. So, right, I'll not want to go in detail this right now. Right? So this is not the end of it. So this is just the performance engineering part, cloud performance engineering part, which I'll be taking up on daily basis. Apart from this, you will be getting Java performance engineering. See, we cannot cover everything on the live session. So I'll be sharing Java performance engineering. eight to 9 hours of Java performance engineering courses, right? It talks about JVM architectures, GC algorithm, GC analysis, thread dump, heap dump, all of this particular, we're gonna share this Java performance engineering, this particular playlist. So we'll be sharing this playlist with all of you, and along with Java coding, because I understand the importance of Java coding from a Java performance point of view. Because at the end, you need to talk about the code. You should be able to talk to the developer. What is the issue? If I tell you take a heap dump or thread dump and you find this issue, you should be in a good position to talk to the developer, right? So that's why we are sharing this kind of Java programming things with you. So these things would be shared along with cell scripting, right? Linux part. So I'll come to the course that we are going to cover here. Look at this. So this is the actual course, and everything is mentioned in this particular course that we are going to cover. So if you talk about the first part, right? So this is going to be a 40 to 45 hours of live sessions, lifetime access to recorded videos, right? The first part, cloud computing. These things will be covered from scratch. Every topic would be covered as you see this here. Linux command line. This is going to be the recorded sessions. I'll be giving you because it's from very basics, and I know some of you are already aware of Linux, so I'll be sharing this as a recorded session. AWS part, most of the things I'll be covering it in the live sessions, but Linux part will be as shared as the recorded session. Okay. Then software architectures, live sessions again, monolithic, microservices, what it is, how the architecture looks like, Docker. We'll talk about Docker container engine. How do you create containers? Different Docker operations that you have, Docker file, Docker images, how do you create containers? How do you Docker compose? How do you create multiple containers in one go? We'll talk about Docker compose. Right. Then we talk about Kubernetes. In detail, Kubernetes. What is Kubernetes? I just showed you EKS and GKE. We'll talk about both. We'll talk about, someone asked multi-container pod, right? The difference between pod and the container, someone was asking. Right? So you can see this multi-container pod. What is pod networking? How it looks like, interpod, intrapod communication, services, node port, cluster IP, load balancer, right? How auto scaling happens. So HPA and auto scale, how auto scaling happens. So horizontal pod autoscaler, cluster autoscale, that's very important from the production, because you don't want to do things manually. You want things to be done in an automated way, right? That's why we need to configure these things. We'll talk about performance engineering, right? And Java performance engineering, CI/CD pipeline, as I talked about, right? So troubleshooting performance bottlenecks, 8 hours of recorded sessions. And this is about the how performance engineering fits in DevOps. So CI/CD pipeline, Jenkins, automated performance testing. We'll talk about all these things. Right? So this is what I'm coming up with, guys. I'm going to share this link with you. Please go over this link. And if you have any questions, looking forward to enroll, you can contact Mr. Kumar Gupta at this number. Or if you want any clarifications on the content that we are covering, you can ask me right now. You can approach me. If you need any more clarifications on what we are going to cover, how we're going to cover, you can ask me right now. We have some time. Right? So I'm going to repeat it again. So we'll be, as part of course, this is going to be the live sessions, first of all. Cloud, microservices, Docker, Kubernetes, CI/CD pipeline, all live sessions from scratch. Apart from that, Java performance engineering. Start from what do we mean by engineering, JVM architectures, GC algorithm, GC log analysis, heap dump analysis, thread dump, all of these things will be taken care here. And shell scripting, recorded session will be shared, and Java coding, right? So these things will be the part of this course, and you have the syllabus. So any questions, if you have, feel free to ask.
Roshan, one thing I would like to ask.
Go ahead.
That there is another course, I think, site reliability engineering. So are these two courses are same or different?
Right. I'll talk about it. Okay. So tomorrow the demo is for SRE. Okay. The course mostly are the same. What I'm going to cover extra in SRE part, I'll talk about it. So I'm gonna share this. Okay. So tomorrow is the demo for the SRE course. Mostly the content is the same. We're gonna talk about more. Okay. On that in that course, we'll talk about what is SRE. First of all, we'll understand it. What is SLO, SLA, SLI? What does it mean? Error rates, right? Error budget rate. We'll talk about incident management, change management, because SRE has a different, unique set of skills that we need to talk about, right? We'll talk about this. So this is the extra part. We will be giving Python recorded session as well in SRE, along with these things. So first of all, this we'll talk about it. We are going to talk about automation more. We can talk about observability. See, observability we cover as part of both the courses. Prometheus, Grafana, ELK will cover in both the courses. I should mention this part in that course as well. Okay, I'll mention this. So observability we cover both in both the courses. Apart from what is more, we cover these things. So we covered Terraform and Ansible as well. So 2 sessions for Terraform, 2 sessions for Ansible. That is what we cover for the automation, because SRE also needs automation, infrastructure automation. So we talk about Terraform and Ansible. Apart from that, this will be shared in this course as well. The Cloud PE course, shell scripting would be shared. Apart from this, we also share Python. So 30 hours of Python course for SRE. That we don't share for Cloud PE course. So if you ask me what is extra things, Python we share only for the SRE. We talk about toil and automation, eliminating toil and automation only for the SRE. And we talk about SRE concepts only for the SRE. So around 7 to 8 hours of these things along with Python. We share extra things with SRE. Apart from that, it's the same.
Okay. So whatever is there in the cloud performance engineering, that is plus these additional things in the site reliability.
Exactly.
Okay.
Exactly.
Okay. Thanks.
I'll share this link with you. Yes.
Hi, this is Padma. I have a question.
Sure. Go ahead, Padma. Yeah. Go ahead.
So this cloud performance engineering is based on Python programming or Java based?
See, cloud performance engineering, first understand, we are talking about cloud. So cloud is not based on any technology. Cloud is a platform, right? Cloud is a platform. Microservices is a architecture. We talk about Docker, Kubernetes. It is not Java based. What is covered, we are covering in the cloud performance engineering, Java performance engineering. I hope if you're from performance background, you would be able to understand that in the Java performance engineering, we talk about troubleshooting Java applications. How do we troubleshoot? If you have, let's say, memory leakage, with every GC, you find that memory is growing, right? So when we take the memory graph over the time, you find that, let's say, leakage is happening. So what do you do in such a scenario? You mostly take a heap dump, try to analyze which particular object is creating a lot of space, right? And how do you find the method, and what will you suggest to the developer? Let's say you find the object, you find the method, you are seeing the code, Java code, but you should be able to understand the Java code here. So as part of Cloud PE, we are talking about first of all, from the infrastructure performance engineering, cloud performance engineering, Kubernetes, containers. Those are not related to Java. This is what is developed, what is there in Java. This is part is only thing in Java performance engineering, Java coding. So these things are only in Java. Apart from that, there is no Java. You don't need to. This is what the Java context is. I hope it makes sense.
Yeah. So like pod deployment, right? Pod deployment is in Jenkins. We do
Pod
in
deployment.
Jenkins.
See, how do you deploy a pod? You have a container, correct? You have an image.
Java.
you have an image.
Java container, Docker
You
container.
have an
Okay.
image, correct? So image could be developed in any language. You don't bother about this. You get a container image on which, so basically container image your microservices. Which language they have created the image, no problem. It could be developed in Go language, Java language, or Node.js or Python. Doesn't matter. How it matters, how do you deploy in the pod? We'll use kubectl command. Kubectl command to deploy this image on the pod. We'll talk about this. How do we deploy things? It doesn't matter this image is developed in which language. The deployment part is same. That's how this technology is, container technology. It makes you independent of what the code language you are developed in, because end of the day you get image, container image. Able to follow? No?
Yeah. So you are using the sample image, like
Exactly. If you go to hub.docker.com, let's say if I
Mhm.
take you to the website hub.docker.com, you're going to find a lot of images here, right? Lot of images for web server, MySQL images. Let's say I want web server. HTTPD is from a web server. It is from Apache. It's a web server. I can run this image to create a pod, a container. I can use this database, MySQL. This could be developed in any language. I don't care. I can deploy this MySQL image and I can create a database pod. Let's say Tomcat. I know this particular image would be developed in Java, but it does not require Java knowledge to deploy this particular image to create a pod or container. It does not require that. That's what the container technology is all about.
Okay. So about Elasticsearch, do we have image for Elasticsearch too?
Correct. ELK, right? So ELK is three things, right? Elastic is three things: Elasticsearch, Logstacks, and Kibana. ELK, when you say, what do you mean by ELK? E stands for Elasticsearch. You have an image for this. L stands for Logstacks. You have an image for this. And K stands for Kibana. You have an image for this. And that's what is. In the observability part, that's what I will talk about this. In the Prometheus and Grafana and ELK, that's what I will demonstrate things. How do you deploy things? How do you monitor things? I will talk about these things. I hope it makes sense now, Padma?
Yeah. Thanks. Yeah.
Sure. Any more questions, guys? We have 9 minutes. If you need any more information on these courses, Cloud P or SRE courses, feel free to ask me any question.
What will be the timing, Roshan, for this course?
Okay, so the timing would be the same timing as what we are meeting right now, 9 p.m. To 10 p.m. right? 9 p.m. to 10 p.m. Or 9 till 10:15. I may extend the session, right? Mostly this would be the timing. And also I am proposing a time slot for the weekdays morning. IST I'm talking about, okay? If someone from international time zone has joined, so I'm talking in the IST time zone, guys. 9 p.m. to 10:15 p.m. IST, okay? And I'll be also taking up if in the Saturday, Sunday, 7:30 to 8:30 a.m. So see, I'm talking about Monday to Thursday, 4 sessions here, 2 sessions here, 6 sessions. I'll be mostly taking up 4 sessions in 1 week, 4 to 5 sessions, okay? Depending on, so I'm giving you this for the 6 days, depending on preference. So 6 days options are there. I'm keeping the 6 days options in a week, but depending on the preference, which time we are preferring and of my availability, right? We'll be definitely taking up 4 sessions in a week. Definitely 4 sessions every week is must. And we have around 40 sessions. So definitely we need to cover. So it takes around 2 months, guys. 2 months we need to cover this. So 4 to 5 sessions we cover in every week. This will be the timing. So 9 p.m. to 10:15 p.m. If you skip, let's say Wednesday, if you take a break, Monday, Tuesday, if you want to take Wednesday break, we can go Thursday, and we can meet any one of these days. So 4 to 5 sessions in a week. That's what would be covered. Yeah? 1 hour. In week,
Okay, thanks.
we can cover. We can take 1.5 hour, 1.5 hours, because we have time in the morning time. We can cover, and we can close. We can complete the batch in 1.5 months. It depends. So 1.5 months to 2 months, you need to keep a tab that will complete the batch.
Is there a homework also? Homework sessions or?
Please come again.
So are you providing the homework as well after each
Yeah.
class?
Homework would be like whatever I'm gonna see. Everything is hands-on. Okay, I'm going to demonstrate everything in the Cloud Console, AWS, or I'll create Linux instance, Docker, Kubernetes. Everything is hands-on. So homework is simple. Repeat whatever I'm doing. That is what unsaid homework. So you're supposed to complete whatever I'm covering. If you do that in 2 months, you're gonna have immense difference in your knowledge, and you can find from this real feedback. Okay, we have taken these real feedbacks for you to get comfortable, and so if you see the feedbacks, it must be there somewhere. Okay, so okay, let me check this cloud. Look at this. These are the real feedbacks. So you can read through this. People have been immensely benefited. So these are the real feedbacks. You can read through this link. You will understand.
Yeah. Okay. I joined this late. So is there a recorded session for a demo?
Exactly. We are recording. Right now we are recording. You're gonna find everything in the recorded session. Yeah.
Okay. So is it cloud formation covered in AWS? Cloud
Cloud
formation concept.
formation we are not covering as of now. We are covering Terraform in SRE course. Okay. So cloud formation is infrastructure provisioning, right? We want to create infrastructure. So basically we're talking about, we don't want, cloud formation is only for the AWS, right? I hope you're aware. Only for,
yeah, right.
but if you use Terraform, it is for the any cloud, AWS, Azure, GCP, anything, OCI. So we are talking about Terraform in the SRE course, Site Reliability Engineering course.
So is it covered in cloud formation engineering?
Cloud performance we are not covering.
Yeah, cloud.
So if you're looking for Terraform, you might be interested in taking up this SRE course, because we are in Terraform there.
Okay.
So there are 2 links I have already shared. So go over these 2 links. So I'll again repeat it. What is extra thing is there? This thing is extra. Okay, in SRE course, I can provide recorded videos for Cloud PE guys as well. That's fine. But this is extra. I'll taking up live. Okay, and apart from Python coding and this site reliability concept, this is going to be extra. Some 8 hours of recorded sessions would be extra. 7 to 8 hours of recorded sessions would be extra for SRE course. This is going to be extra only for the SRE. Because you need to decide now, because you want to pursue in performance engineering part, or you want to go to SRE part. That you can decide. We are giving you both the options.
So are you providing interview based questions or?
Yeah, that can be provided. Okay, that can, once you understand, once you learn these things right, you will be confident to on your own. So yeah, we are doing that.
Okay.
I'll give you pointers to put in your resume. All those things can be done.
Thank you.
Sure. Any question, guys? We have 2 minutes.
Roshan, another thing, since we'll be covering AWS for most of the session.
Yeah.
So after this session, I think if I want to take up maybe Azure or GCP, will this be helpful for me, right?
See, all the cloud service providers are very much similar. Understand this. So if I talk about AWS, if you have, let's say in AWS, we have compute servers. So we call it EC2 in AWS. So the same compute, we call it virtual machines in Azure. The concept part is same. Only the UI would change. In GCP, we call it compute engine. Right? Only thing would be that. Only difference would be that. So if I have to show you, right, let me just show you. So let's see if I'm going to show you AWS, how this it looks. See, core concepts is same across any cloud service provider. They will have compute, they will have storage service, they will have databases. All these things are the same. Only thing what would be different is the UI part. In AWS, you call it EC2, right? If I log into AWS, I call it EC2, right? You have so many services in AWS. Look at this. I'll show you like this. In the compute, if you go to compute, you call it EC2. That's how you'll get the cloud. If you go to in AWS, if you go to storage, right? If I take you to the storage service, I call it S3. Same thing if I show you in GCP, let's say that. If I have to show you the same thing in GCP, we call it compute engine or cloud storage for S3. So the core concept remains the same. That's how I have learned, right? I started with one of the cloud service providers, right? And then it was easy for me to pick others, right? It's not like someone has to teach me everything, right? Nothing like that. It was a self-learning for me. Once I have struggled and learned one of the cloud service providers, it's easy for me, right? See, EC2 we call it, right? Here we call it compute engine. The use case is still the same. The UI part looks different. Here I call it cloud storage bucket. There we call it S3. So similar service. We have BigQuery here, right? In the world. So there they call it SQL. So the database also same, relational, non-relational. In AWS also we have it. In Azure, GCP also we have it. So the UI part would change, but the core concept would remain the same. Okay, I hope.
Okay, understood. Yeah, thanks, Vasu.
Sure. Okay, guys. So that's all for today's session. I hope you have the link with you, right? Thank you so much for attending it. I hope you learned something in this 1 hour, right? So thank you so much, guys. We hope to see you soon. Thank you.